Welcome to your review for the Geometry Honors Chapter 11 test. The first problem we're going to look at is a small word problem, but the problem itself is really quite easy. Mario's company makes unusually shaped imitation gemstones. One gemstone had 15 faces and 12 vertices. How many edges did the gemstone have? So what we need to do here is we need to think about that Euler's formula. So think back to Euler's formula. Now, Euler's formula tells us that F plus V equals E plus 2. So we've got this 3D prism type gemstone, and they told us that we have 15 faces and 12 vertices. They want to know how many edges we have. So 15 plus 12 is 27. That equals E plus 2. I'm going to subtract 2 from each side. And I end up with the fact that I have 25 edges. This next problem is talking about a box that we need to wrap so that this jewelry store can sell it. And it gives us a diagram and then asks us to find the lateral area and the surface area of the box to the nearest whole number. So first we need to start out with lateral area. My formula for lateral area of a rectangular prism is perimeter times height. So looking at my base, see that my base is these two rectangles here. Those are my bases. So my perimeter is going to be 12 plus 12 plus 5 plus 5. 12 plus 12 plus 5 plus 5 gives us a total perimeter of 34 centimeters. Now my height is defined as the distance between my bases. So the distance between my two bases is right here. It's 2.45 centimeters. So let's plug those into our formula. 34 times 2.45, which gives me a lateral area of 83.3, and since we're supposed to round to the nearest whole number, 83 centimeters squared. That's my lateral area. Now to find my surface area, I need to go ahead and add my two bases to that. So surface area equals lateral area plus 2b. Now our lateral area we said is 83. The area of my base, well, since it's just a rectangle, it's going to be, let's do this off to the side here. My base is just 12 times 5. 12 times 5, we know is going to be 60. So we're going to plug that in right here. I need two of those bases, but then I need to add that to my 83. So my total surface area is 203 centimeters squared. So we've got our lateral area here, our surface area here. So this problem we're asked to do the same thing. We need to find the lateral area and the surface area of the given prism, round to the nearest whole number. So same idea, except here I don't just have a box, which is a rectangular prism. I have a different prism, and it's really important to note here that your bases are these two triangles. Your bases are not rectangles in this case, they're triangles. So when I do this problem, that's going to change it just the slightest bit. I do start out the same way. I know that my lateral area is going to be my perimeter times my height. Now in order to find my perimeter though, I need to recognize that I do have my two measures here for my legs, but then the hypotenuse, they didn't give it to me right here, they gave it to me over here. But I know that that's going to be the same value, so I'm just going to write 6.32 meters in there as well. So then my perimeter is 2 plus 6 plus 6.32. 2 plus 6.6.32. Oh geez. Sorry. 2 plus 6 plus 6.32 gives me 14.32 meters is my perimeter. So let's plug that in. And then our height is the distance between our two bases. So our height is 36 meters. So we're going to go ahead and multiply those two numbers. And our lateral area ends up being 516, because I have to round up since I get 515.52. And that's meters squared. So there's my lateral area. For surface area, I use lateral area plus 2b. So I plug in my lateral area, 516. Now my base area, I'm going to do that off to the side here. Now I have a triangle. So for a triangle, I know the area of a triangle is 1/2 base times height. And I need to notice that I have a right angle here, which means my base and my height are the 2 and the 6. So 1/2, 2 times 6. That gives me a base area of 6. So I'm going to plug that in here. And I have 516 plus 2 times 6, which is 12, gives me a surface area of 528 meters squared. All right, so in this picture, we're looking at a cylinder. We need to find the surface area of the cylinder in terms of pi. So surface area of a cylinder. Well, I know that's going to be my lateral area plus 2b. My lateral area is circumference, 2 pi r, because that's like your perimeter, times my height, so 2 pi rh, plus 2 bases. My bases are circles, which is pi r squared. So I'm just going to plug into that whole formula. Now, they did tell me that my diameter is 8. I need to recognize my radius is 4, because that's what I actually have to plug in. So 2 pi 4, my height is 17, plus 2 pi 4 squared. That equals, let's see, 2 times 4 times 17. I'm not going to multiply the pi in because it said leave it in terms of pi. So that gives me 136 pi plus 4 squared is 16 times 2 is 32 pi. And then I'm going to add those two values together, and I get a surface area of 168 pi centimeters squared. This next problem, we're now looking at a pyramid versus a prism. Now, a pyramid, my formula for surface area changes a little bit. Remember, we need to round to the nearest whole number. So surface area equals 1/2 my perimeter times my slant height plus my base. So they did give me my slant height here. It's this piece here, which they told me is 7. So my perimeter, well, 3, 3, 3, and 3. So let's start doing some work here. My perimeter is going to be 3 plus 3 plus 3 plus 3, which is 12 feet. My slant height, they told me, is 7 feet. We need to find the area of my base. Because I know it's a square, I just do 3 times 3, which equals 9. So now I can plug these things in. 1/2, 12 times 7 plus 9. So let's do that. I get that my surface area equals 51 feet squared. For this problem, they're simply asking us to find our slant height. So they've given us our height. This is one of my side lengths, which is 9. So if I go ahead in here and finish off this triangle, I know that that piece is going to be 4.5 because it's going to be half of my whole side that's 9 here. So now all I have to do is use Pythagorean theorem. I know that 4.5 squared plus 8 squared, because those are my two legs, will equal x squared, my hypotenuse or my slant height. So 4.5 squared is 20.25. 8 squared is 64. If I add those two things together, I get 84.25 equal to x squared. And then I just have to take the square root of that, which gives me a slant height to the nearest tenth. That's what they wanted us to do. So nearest tenth, I get x equals 9.2 millimeters. That's my slant height. All right, so here I'm going to be looking for my lateral area and my surface area of this cone. The first thing I have to do is figure out my formulas for lateral area and surface area. So lateral area is going to be 1/2 my perimeter, which in a circle is circumference, so 2 pi r, times my slant height. Now the other formula that you could remember, this is not on the reference sheet, the one that I just wrote is on the reference sheet, but this 1/2 and this 2 cancel out, so you're just left with pi r l for slant height. And then my surface area is going to be my lateral area plus a base, and in this case I know my base is a circle, so lateral area plus pi r squared. So let's go ahead and start figuring out some values here. I've got pi, my radius they told me is 12, my slant height they told me is 21. All right, so 21 times 12, my answer I get here, it says round to the nearest tenth, so I need to multiply pi in. 252 pi equals 791.7 when I round to the nearest tenth. And my units are feet squared. So that's my lateral area. And then I'm going to plug that in over here on my surface area formula. 791.7. Oops, that should be a plus sign there. Plus pi, my radius we said was 12 squared. Put all that in my calculator, and I get 1,244.1 when I round. Feet squared is my surface area. So I found my lateral area and my surface area, and I rounded to the nearest tenth. All right, so now we're starting to look at volume. I have volume of a prism. So volume equals the area of my base times my height. Well, in this prism, the area of my base is just going to be base times height, which is 15.6 times 2.1. So 15.6 times 2.1, the area of my base is 32.76. So I'm going to plug that into my formula over here. 32.76 times my height. My height that they gave me is 8. So my volume, and it says round to the nearest tenth if necessary, is 262.1 centimeters cubed. So here I'm looking for volume again, and I'm going to round to nearest tenth again, but I do need to take into consideration the fact that my base is now a triangle. So my formula, V equals big B H. Big B is not just base times height anymore. It's 1/2 base times height. So 1/2 2 times 1, which means my base is just 1 meter squared. So let's plug that into our equation over here. Volume equals 1 times my height is 17. So volume equals 17 meters cubed. This problem is going to have us work a little bit backwards because they told us the volume of our cylinder They told us the height of our cylinder. They want us to find the radius. So in order to do this, I need to think of what the formula to find the volume of a cylinder would be. So formula for the volume of a cylinder. So volume equals, if I have a cylinder, I need, well, it's just big B times H, but it is going to be a little bit more specific because my base, the area of my base, is a circle, so it's pi r squared times my height. All right, so there's my formula, but they told me that that's equal to 980 pi. They also told me that the height is 20, so let's plug that in. I have pi r squared times 20 equals 980 pi. Now I need to solve for radius. This is my goal, get the radius by itself. So in order to do that, I'm going to have to divide this 20 here and this pi so that they cancel. That means I'm going to have to divide by 20 and pi on the right side. My pi's go away, and then I need to do 980 divided by 20. I get r squared equals 49. Well, now that's r squared. I don't want r squared, I want r. So I have to take the square root of both sides, leaving me with that my radius is 7 inches. All right, number 11. Cylinder A, oh, I have a lot of information here. I'm going to make a chart real quick. Whoops. So I've got cylinder A, I've got cylinder B. Cylinder A, my radius is 1 and my height is 4. Cylinder B, my radius is 2, my height is 4. Find the ratio of the volume of cylinder A to the volume of cylinder B. Okay, that's my goal, A to B. So volume. Volume of a cylinder is pi r squared h. All right, so let's use this formula and let's find the volume of A and the volume of B. So volume of A is pi r squared h. Volume of B is pi r squared h. Let's multiply those out. Volume of A, I get 4 pi. Volume of B, I get 16 pi. So I've got my two volumes, which is a good start. Now I need to find the ratio of A to B. Now I can either write it in ratio form like this with a colon, or so that I can make sure I'm simplifying properly, I'm going to put A over B. A to B. Now this simplifies though. So I'm going to go ahead and I'm going to simplify as much as I can. My 4 and my 16 will simplify to 1 over 4. And my pi's completely cancel out. So I'm left with a ratio, my volume of A to my volume of B, of 1/4. Okay, so now we've got a composite space figure. I need to round to the nearest whole number. I see that I have a rectangular prism and half of a cylinder. So I need to figure out the volume of my prism and half of my volume of my cylinder. I need to add them together. So let's get to work. Volume of my prism. Okay, that's going to be the area of my base times my height. My base is going to be, well, 5 times 10 is 50. 5 times 10, that's the area of my base. My height is this 4 here, so I'm going to plug that in. 50 times 4 gets me 200 millimeters cubed. So that's the area of, the volume of my prism. Now I need to find the volume of my cylinder. That's going to be, again, big BH, but in this case, big B is pi r squared because it's a circle, right? It's a cylinder. So my radius, they didn't specifically tell me that. But if I know that this whole piece here is 5, then I know my radius is 2.5. So let's plug that in. Radius is 2.5. Now my height. My height of my cylinder is the distance between my bases, which is this piece right here. So that's my 10. So I've got 2.5 times 10. That gives me 25 pi. Now, because I need to add that, I'm going to have to get it into a decimal, but let's not do that quite yet. I have volume of my prism, 200 millimeters cubed, plus I only want half of my cylinder, which we found was 25 pi millimeters cubed. So now let's go ahead. Let's take a look at this 25 pi. 25 pi as a decimal is 78.53981634. But I want half of that number. So let's divide that by 2. I get 200 plus 39.26990817. So let's add that 200. Now it does say round to the nearest whole number. So when I do that, my answer is 239 millimeters cubed. That's the volume of that entire composite figure when I add the volume of my prism plus the volume, half of the volume of my cylinder. All right, now we're looking at volume of a pyramid. I'm rounding to the nearest tenth. Okay, so volume of a pyramid. V equals 1/3. I know it's going to be 1/3 because it's coming to a point. It's a pyramid. 1/3 area of my base times my height. Well, because it tells me it's a square pyramid, I know that my base area is just going to be 24 times 24, which gives me 576. And then the only other issue I have is they provide me with my slant height, but I need my height. So I'm going to have to go ahead in here and I'm going to drop my height down and I'm going to create that right triangle. And I know this piece is going to be 12 because it's half of the 24 that's my side length. And now I have Pythagorean theorem that I have to set up. So let's do that off to the side here. I've got my height squared, which I'm not sure, that's what I'm looking for, plus my 12 squared equals 13 squared. Remember, your slant height here is always your hypotenuse of your right triangle. So height squared plus 144 equals 169. I'm going to subtract my 144. I get height squared equals 169 minus 144 is 25. Take the square root. Well, look at that. My height's 5. Okay, so I'm going to put that into my picture. That's really helpful. And now I'm just going to plug that into the formula. So I've got my volume equals 1/3. My base area was 576. And my height we just solved to be 5 using Pythagorean theorem. So now 5 times 576 times 1/3, my volume is 960 feet cubed. All right, we've got another volume problem. This time it's a cone, not a pyramid. So I need my volume formula, which is 1/3 area of my base times my height. But I know because this is a circle, the area of my base is just going to be pi r squared. They gave me the diameter, but I know that this is half, so my radius is 6. So let's plug that in to find the area of our base. Now we know the area of our base. Sorry, that's really ugly B. the area of our base is equal to 36 pi. Now it does say round to nearest tenth, so as soon as I see that pi, I have to think about how I'm going to write my answer. We'll round at the very end though. So I'm going to put that into my formula. V equals 1/3. The area of my base was 36 pi. My height, they did actually give me my height. It's right here, 22. So let's go ahead and multiply that all out. I've got the fraction 1/3 times 36 pi times 22 gets me 264 pi. But because it says round to the nearest tenth, I'm going to hit my double arrow button, and I get the answer of 829.4, when you round to nearest tenth, meters cubed. All right, surface area of a sphere. Whoa, boy. Almost lost it there. Surface area of a sphere is the next problem that we've got. It says leave your answer in terms of pi. All right, so let's figure out what our formula is. We've got surface area of a sphere is equal to 4 pi r squared. They give us the radius right there. It's 80 meters. So let's go ahead and plug that in. 4 pi times 80 squared. Put this into our calculator. 80 squared, it's a big number, 6,400. And I need to multiply that by 4 pi. So my surface area for this sphere is 25,600 pi. This next problem asks us for the volume of a sphere. So volume of a sphere is equal to 4/3 pi r cubed. Now, even though they didn't give us our radius in this picture, we know we can just cut 13 in half and get that our radius is equal to 6.5. So now we can go ahead and we can plug that in there. And in our calculator, we can do 6.5 cubed by hitting that caret button that's 4 below the green second button. 6.5 cubed times 4/3 pi equals, my volume is, oh, and it says round to the nearest cubic unit. So I've got 1,150. I rounded down because it was 0.34651 centimeters cubed. Okay, so here we're working backwards again. We did one other problem like this. The volume of my sphere is 4,500 pi meters cubed. What is the surface area of the sphere to the nearest square meter? So if you think about volume of a sphere, our formula is 4/3 pi r cubed. But they told me that it's 4,500 pi. I need to get my radius by itself. So what I'm going to do is first get rid of this pi. I'll cross that out on both sides. I get 4/3. My radius cubed is equal to 4,500. Now, to get rid of this 4/3, I'm going to multiply by the reciprocal on both sides, which is 3/4. That makes it cancel on the left, and I'm just left with the r cubed. And then 4,500 times 3/4 is 3,375. Now, that's r cubed, but I don't care about that. I need to take the cubed root of that value. Now remember, you have to hit the second caret button so we get that little x radical. So do 3 second caret. That gives me my cubed root of 3375. My radius equals 15. So we just solved for our radius, which is a great first step, but it's not what it asked for. It asked us for surface area of the sphere. So now we just have to plug this back in. Surface area equals 4 pi r squared. So if my radius is 15, 15 squared times 4 pi gives me 900 pi. And it does ask to the nearest square meter. So we're going to hit our double arrow button. And that gives us 2,827 when we round down because it's 0.4. And our units are going to be meters squared. That's the surface area of that sphere. This next question starts getting into similarity between figures. Now, it's really important that you know we're comparing these two figures to each other. We're not comparing dimensions within the figures. We're comparing between. So it says give the similarity ratio of the smaller figure to the larger figure. So we're going to do everything as small over large because that's what it's asking for, small to large. Now what I need to do is I need to match up these three dimensions that they've given me. Here I have a 5. Here in that same spot, but on the other shape, I have the 20. So I'm going to write 5 over 20. Now here I have a 5. And in that same spot on the other shape, I have a 20. So I'm going to write 5 over 20. Here I have a 17. In that same spot on the other figure, I have a 68. So 17 over 68. And now what I'm going to do is I'm going to reduce and see if all of these get me to the same thing. So 5 and 20, they do have a common factor. I can divide 5 by 5, I get 1, and 20 by 5, I get 4. So that's 1/4. Obviously, this next 5 over 20 also reduces to 1/4. Now I need to see, does 17 over 68 reduce to 1/4? And yes, it does. It does reduce to 1/4. So that's a good thing. They are similar. And I know that my similarity ratio is 1 to 4. All right, this next one asks me to find the similarity ratio of a cube with volume 343 and a cube with volume 2,744. Now, it's very important that we remember we have similarity ratio, which is equal to like your perimeter ratio, or any single dimension. But then once we get to area and volume, area is my similarity ratio, or my scale factor, it's another word for it, squared. And volume is my similarity ratio cubed. So if they give me my volume, I have 343 over 2,744. That's my volume ratio. And that's helpful, but that's not what I'm interested in. So what I need to do is I need to go backwards from volume to my similarity ratio. And the way I'm going to do that is by taking the cubed root of this. That whole thing. And in your calculator, you can do that. Remember, you hit 3, second, the caret button, which gives you that x radical. Now you have a fraction button that you can put into your calculator. 343 divided by 2,744. And what you end up with is a simplified answer of 1/2. Now, if you do that all in one step, your calculator will simplify it for you. But if you take the cubed root of 343, let me show you what it came from. Cubed root of 343 is 7. If I take the cubed root of 2,744. That's 14. So your calculator automatically reduces that 7 over 14 to get your final answer of 1/2. So that is your similarity ratio. So this is going back to what I just had on the last slide. If the scale factor of two similar solids is 5 to 8, or we can write that as the fraction 5 over 8, what is the ratio of their corresponding areas, and what is the ratio of their corresponding volumes? So this is my scale factor. If I want area, square it. If I want volume, cube it. So for area, I'm going to take 5 over 8, and I'm going to square both of those values. I get 25 over 64. 25 over 64 does not reduce, so that's my final answer, 25 over 64. Volume, I'm going to take that 5 over 8, and I'm going to cube it. 5 to the third power is 125. 8 to the third power is 512. Can I reduce that? No. So that is my answer. This is my area ratio. This is my volume ratio. So it's very important to remember that we have our scale factor or our similarity ratio, and then to get to our area, we square it, and to get to our volume, we cube it. Going backwards, we might have to use a square root or a cubed root.